Okay, so let's work on this example here of uh, finding partial derivatives when you need to use implicit differentiation. So the first thing we want to do is find the partial of z with respect to x. Okay, so our goal is going to be computing zx. Okay, now I'm starting off with my equation here, which is x cubed plus y cubed plus z cubed plus 6xyz equals 1. First thing I'm going to do is I'm going to take the partial with respect to x of both sides of the equation. So partial with respect to x of 1. Now, on the left-hand side, of course, I can split this up. Now, the partial with respect to x of x cubed plus the partial of y cubed plus the partial of z cubed plus the partial of 6xyz. On the right-hand side, I'm just going to have 0 because the partial of 1 is equal to 0. Okay, now the partial of x cubed with respect to x, that is just going to be 3x squared. The partial of y cubed, that's just going to be 0. Because remember, if we are drawing our tree showing the relationship, z depends on x and y. Y doesn't depend on x, right? And if we had a situation like this, then, we'd have something a little different. But that's not how our tree is set up. Our tree is set up so that z depends on x and y, which means this partial of y cubed with respect to x is going to be 0. Now, how about the partial of z cubed? So this will be 3, I'm using the chain rule now, 3z squared times the partial of z with respect to x. Okay? And over here, to break this down, I'm going to first notice that y and 6 are constants, so I can bring them out front, right? So this is going to be equal to 6y times the partial of x times z. And now I need to use the product rule because z depends on x. So I'll get the partial of x with respect to x times z plus x times the partial of z with respect to x. And all of this is being multiplied by 6y. The partial of x with respect to x is just 1. And the partial of z with respect to x, well, that's exactly what I'm trying to solve for. Right? So I can't simplify that any further. So now I'm just going to expand. So I'll get this times that will be 6yz plus 6y times this is going to be 6xyzx. Okay? So putting all of this together, we see that 3x squared plus 3z squared z sub x plus 6yz plus 6xy z sub x is equal to 0. Okay, so my goal, remember, is to compute z sub x. So I'm now going to solve for z sub x. How am I going to do it? I'm going to subtract 3x squared from both sides. I'm also going to subtract this 6yz. The reason why is because, look here, so this term involves z sub x, this term involves z sub x. So I'm now left with 3z squared z sub x plus 6xy z sub x is equal to negative 3x squared minus 6yz. So I can now factor out a z sub x, and I'll get 3z squared plus 6xy times z sub x is equal to negative 3x squared minus 6yz. So I can divide both sides by 3z squared plus 6xy. And I end up with z sub x equals, now on the right, I actually can simplify because each of these coefficients is divisible by 3. So I can just have negative, I'm pull the negative out. So I have negative, let's see, so that'll be negative x squared plus yz divided by z squared plus xy. And that is my final answer. Okay, so let's practice. Let's practice. What I would like to do is practice also finding the partial with respect to y. Okay, so now this time I'm going to go a little faster, and I'm going to say the partial with respect to y, x cubed plus y cubed plus z cubed plus 6xyz is equal to the partial with respect to y of 1. So on the right-hand side, that's going to be equal to 0. That, when I take that partial, that's going to be 0. That partial is going to give me 3y squared. That partial is going to be 3z squared z sub y. Now I'll have 6x times, I'm going to do the product rule. So it's the partial of y, that'll be 1, times z, plus y times the partial of z with respect to y, and that's just z sub y. So putting it all together, 3y squared, where is this? 3y squared plus 3z squared z sub y plus 6xz plus 6xyz sub y is equal to 0. I'm going to factor out the z sub y, and I'll have 3z squared plus 6xy times z sub y on one side, and negative 3y squared plus 6xz on the other. And now I'm just going to divide both sides. So I'll get z sub y equals negative y squared plus 2xz divided by z squared plus 2xy. So the only thing I did there was I divided by 3, the numerator and the denominator, so I ended up simplifying. Okay, so that's my final answer. And you'll notice that this is very, very similar to the partial with respect to x. And the reason why is because the relationship between z and z and y is symmetric. So the partials are going to be the same, just switch the x's and the z's. Okay, that's it for our examples.